Conservation of volume is a really interesting stage. And the way it works is this. You take, let's say, 2 equal pitchers of water, and you have a kid, say 5 years old, pour one pitcher into a glass that is very big and very short, and another pour the water into a glass that's very tall but narrow. And then you ask the kid which container has more, which of the two glasses. And under a certain age, they say the tall one. And over a certain age, they say, are you a doctor? It's obvious. These two are the same. Let me show you an example, which I think is taken from the latter, from your textbook. Here's the picture from the textbook on 303. And it shows the two containers, tall, skinny, shorter, wider. And the expression on the kid's face is priceless. Obviously, this kid is thinking, you must not be very smart to have asked me the question of which one has more. They're the same. Another fascinating example is if you take a kid and sit them in front of a screen, say 4 feet wide and about 3 feet tall, and you take a ball and you roll it behind the screen, and eventually it will come out the other side. Below a certain age, the kid's eyes remain fixated on the place where the ball disappeared behind the screen. And then when it rolls out the other side, the eyes jump. And that is exactly what a lizard does. But after a certain age, the kid obviously gets the capacity to compute what's happening in time and in space, to make a model in the kid's mind of what's going on in the world. And you see that because when the ball is rolled behind the screen, the kid's eyes jump to the other side of the screen. And if the ball doesn't come out in about the right time, the kid shows surprise, like some force acted on the ball to make it come out faster or to hold it back. So this is another developmental stage. And there's many of these things in infancy which really illustrate how the mind seems to be putting things together, the ability to combine various features to make a model of the mind or of the object. And these are the things that contribute to the stages in development. So this is a fundamental principle that we'll take up in class when we talk about very high-level functions, as I mentioned in the first clip, such as things that go on in the prefrontal cortex in adolescence, where you make trade-offs and try to decide if this behavior is risky or not.